I'm in a kind of an interesting situation here this morning in that I'm going to talk to you about a concept that is really become an article of faith for the Dow Chemical Company over the years. And I've also got some colleagues in the audience who probably, well, there's no probably, they do know more about this than I do, and are every bit as committed and passionate to the concept as I am, probably more so. It's on, yeah. So I should preface my comments with, and I joke about this in some presentations I give, as you know, as you may have picked up from my bio, I am not a control engineer. I mean, my background is in chemical engineering, but I'm not a control engineer. My job is basically systems design and consultation in support of and assisting control engineers. So I'd have to know a lot about it, but I'm not really a practitioner. But anyway, with that caveat in mind, I'm going to talk a little bit about what hot loading is and basically why is it important. Let me just flip through these. This first slide just gives you a very quick overview of where we've been and have come from as a company. As probably most of you, if you know anything about Dow, have heard at one time or another, we developed and built our own proprietary control system over a period of decades. And this slide just gives you a little bit of a timeline of some of the major features of that system as it evolved. Now, the reason this is in here is to give you a sense that this is not a sort of a flash-in-the-pan concept. This is not something that just came up overnight. This idea that not just hot loading, but some of the other intrinsic capabilities of what we consider to be a competent control system have been in the formative stage and have been baked into our system for a very, very long time. Going back to the early 70s, actually into the 1960s, which probably isn't really shown on this slide. So Dave touched on a little bit of what is this and what are the challenges and what are the challenges faced by people using control systems when it comes time to change something. And I will stress that we're talking about not just changing the system software, but updating and modifying and changing the control strategy running in the system. That happens probably more often than a system upgrade. And in order to do that effectively, you want to be able to do it as seamlessly, bumplessly as possible in order to continually improve the capability and the fidelity and the importance and the performance of your control system. And so in Dow, we have we do that maybe more often than other people do. As opposed to putting in a control strategy and running it that way for a long time, we're always tweaking it, always trying to improve it, always trying to make the plant run a little bit better. And because of that, the configuration changes quite often. And in order to make that change without impacting the process, you really need to be able to get to those benefits quickly, get to them without disrupting the plant. So it's a touched on here, functionality, updates and changes, testing against simulation models. It's basically always looking for ways to make the process work better. And transitioning between old and new, calculating, looking at, if you're going to make the change, you want to be able to say, okay, it's currently running this way, the logic is running this way, these are the outputs, this is the result of the control logic, and I've got new control logic I want to put in place. What is the result of that change? You can do that theoretically, and sort of, you design both of them and you say, well, I designed it to behave differently, so it should behave differently. But none of us are perfect, so you need to be able to check old versus new and do this in such a way that you don't interrupt the process in the process of doing it. So a little bit on our experience. I talked a little bit about our Mod 5 control system. We've been doing this for a very long time in our own systems. And it's as we started working with commercial vendors, one of the challenges that we faced was explaining even to vendors, why is this important? And it's a little bit like, I don't know, I'm trying to think of an analogy, but ask somebody, why something is important if it's all they've ever known. And I used the term earlier, it's an article of faith. Our control engineers just have come to operate with this capability available to them. So when you come to them and say, well, why is this an important requirement? We had to really scratch our heads for a while and say, I got to think about that. And so we actually went through some exercises to try to tie the capability back to real business value because, like I said, it had been so inherent in everything that we do that we didn't even ask that question anymore. As you can see here, the legacy system that we have, all of this is baked into the development environment. It's just an inherent part of the way the control strategies are developed. And the key point here is the ability to run the new and the old system in parallel and to be able to do that evaluation before you basically commit to the change. And then I touched on already the fact that these changes happen frequently. If you really want to be in a continuous improvement kind of model of operating, you want to be able to make changes rapidly and not be afraid to make changes because you're cautious about the implications. It's a little bit like, well, I think I'm going to change this, and I'm going to push the button, close my eyes, and hope for the best. Well, you don't want to do that, right? You want to be able to be relatively assured through more than your experience and your intuition that as you make the change, it's actually going to affect the change in the process that you want, and it's not going to have negative consequences. There's a little statistic down there at the bottom of the slide. 5 to 6% of loads, changes, if you will, are aborted based on the behavior of that new application. So that's where, that is the statistic or a statistic that says, in this case at least, 5 to 6% of the changes, once we evaluated them, we realized that maybe we really didn't want to enable that. And if we didn't have the sort of the load, or the hot loading capability, you wouldn't have had a choice. You would have had to make the change, see the disruption, and then figure out how to back out of it.